The transfer is from the surrounding to the system.
Surrounding to system, sir.
When will it be negative?
When system to surrounding, heat transfers.
Yeah. Now, if the change in the temperature is delta T, keep it as delta T, then the amount of heat that is transferred is going to be rho F delta T.
What is that coefficient, sir?
So, coefficient is nothing but a value which is related to the magnitude or the size of the system. What size or composition that is related to the system. Composition or nature of the system. Coefficient.
Okay, sir.
Okay. Coefficient. Now we're going to try to understand a little bit more. Now Q is what we said.
Coefficient into del T.
C into del T. Okay. Now, how is coefficient T as the heat capacity can be called as the heat capacity. So what is this now?
Q by del T, sir.
Now, when will for del T is equal to 1 degree,
Yes, sir.
what does that mean? So what does heat capacity mean? Heat capacity is nothing but the quantity of heat which is required to change the temperature of a system by 1 degree.
Yes, sir.
So changing the temperature usually for raise. Okay. The heat capacity is nothing but the quantity of heat required to raise the temperature of the system by 1 degree. That is what is. So then there is something called as specific heat capacity and heat capacity.
Molar heat capacity is heat capacity by number of moles.
Good. Specific heat capacity and molar heat capacity. அது இருக்கிறியா ஸ்ரீராம் இதை கவனிக்கிறீங்களா?
Yes, sir.
So here, in case of specific heat capacity, Q is times M times delta T. Q is
Heat.
required to raise the temperature by 1 degree.
This Q is specific heat capacity, sir.
Yeah. Come on, specific heat capacity. Heat capacity is C, isn't it?
Yes, sir.
While M is nothing but the mass. This is in degrees Celsius. Del T is in degrees Celsius.
Yes, sir.
So then, this is your specific. So molar heat capacity is what?
Heat capacity by number of moles.
Capacity, specific uh, heat capacity by number of moles gives you the molar
Heat capacity.
understood.
Yes, sir.
Now, two more heat capacities. Heat capacity at constant volume.
CV, sir.
CV is amount of heat required to raise the temperature of 1 mole of a gas by 1 degree when the volume of the gas is kept constant. So Q is equal to M delta T, but Cm is C by N. Okay. Now,
Sir, how it became CM, sir? How that specific heat capacity become molar heat capacity?
then Cm is equal to what? Heat capacity by number of moles.
Yes, sir.
Okay. Then it is N is equal to 1 and delta T is 1.
Okay.
So for N is equal to 1 mole, delta T is equal to 1 degree. Your Q is equal to what? At a constant volume.
CM, sir. C by N.
Your amount of heat required to raise the temperature of full of a gas by 1 degree when volume of the gas is kept constant. Understood?
Yes, sir.
The volume during this change, during change of the temperature by 1 degree Celsius. Like when you do the same at constant pressure, it becomes capacity at constant pressure. Cp. So Q is equal to C by N delta T. N is equal to 1. Delta. What happens to your C?
Equal to Q, sir. Cp.
The ratio of constant pressure to constant volume by Cv is known as represented by gamma.
Mayer's ratio, sir. Mayer's ratio, no, sir.
Molar heat capacity is the ratio of the molar heat capacities.
Yes, sir.
Can we stop here for today, guys?
Yes, sir.